we're talking about how radar is set up for the operation. So the course outcome, the students should be knowledgeable on the basic setup and function given that the radar is properly set up by the operators. And the learning outcome is the end of this discussion. Students should be able to properly set up radar for the optimum performance and the operation, and its importance of the topic because this topic is vital in acquiring correct and accurate information from the radar when it comes to the real-time information considering any targets and towards the own ship. So, we are the Group 6, performed by the Commission, Digamo, and Dublin. So, number 1 here, let's start about the general procedure of the switch on the radar set. So, the number 1 here is that the visually makes you sure that the scanner is clear. So, you, as a radar operator, may be wondering how radar helps the ship come safely home again. So, the purpose of this hook is to clear up that the question radar performs the old task of finding the targets but uses new methods. If you understand how this task was performed before the development of radar, it will help you to realize the superiority of the radar over any device formerly developed. So the number 1 is visual detection methods and the limitations. Of course, as you make sure that the scanner is clear, ships have used visual lookouts since the early days of sail. So a lookout, however, cannot see through fogs or smoke or darkness for any great distance, and even on a closer day cannot see far beyond the horizon. So such limitations of lookout have hampered ships for centuries and still do, unfortunately. Unfortunately. So the number 2 here is the the critical adjustment control, which is the gain, brilliance, anti-clutter, and anti-ring clutter. So the differentiator to off or the minimum. So it depends to you if you have make it tuning or the fine tuning of its controls. So the number 3 is set the main function which is off, standby, and transmit to standby. So the radar set will then begin to warm up. Certain parts will require time for warming up. And also the number 4 which set range selector switch to desired range scale. Number 5 is set the PL selector switch to the desired position, which is short pulses for normal use and pulse whereby the radar observer has to choose the PL or automatically every time we switch on the set. So in such a case omit this step as it covered by the step 9. So radar overcomes visual limitations. So radar, generally speaking, can reach out beyond the visual horizon. So it can detect through darkness, fog, and smoke as well as through sunshine. You no longer have to wait until the enemy appears over the horizon or the targets. So the several facts about him or her presence, the number, size, course, and the speed. So, and number 6, ensure that the EBL, the ERBL, VRM, and range rings are all off. So by turning down their respective brightness controls. 7 is to set up the presentation mode switch or the RM stabilized or the TM to the RM stabilized mode. Number 8 is to adjust the panel lights to the desired intensity. And the number 9, when the set has warmed up, about 2 or 3 minutes after switching to the standby, set the main function switch to transmit. So, the information given by the radar, so up to this point, we have discussed the functions and without mentioning just how it operates. So, remarking that uses of radar methods and the techniques, now I will give the floor to Peter the Commission so that he can proceed to the next steps. Thank you.
In some sets, instead of transmit, the main function switch is marked short pulse or long pulse, so that the PL has to be selected at the same time as switching on from standby. Set step 5. In such a case, set main function switch to short pulse. 10. Generally, increase the brilliance until the rotating trace becomes visible. Then gradually decrease the brilliance until the rotating trace just disappears. The brilliance has now been set correctly and should not normally require readjustment. If and when the three other critical adjustment controls like gain, anti-clutter, and differentiator, or what we call anti-rain clutter, are all off or at minimum. 11. If a brilliance control is provided separately for the beading marker, turn it down. Unnecessary brightness of the heading marker will, first, cause the heading marker to be broader than necessary. Second, distract the observer's attention from targets when the picture is obtained later. Third, this control will not and must not blank out the heading marker completely. However, the control may be set. 12. Ensure that the electronic center coincides with the geometric center of display. This can be done by switching on the range rings and verifying the outermost ring is completely visible and coincides with the circumference of the PPI. If not centered properly, part of that range ring would not be visible. If necessary, center the picture by rotating the center shift as required. 13. Check that the heading marker is properly aligned. When gyro is stabilized, it should indicate the correct gyro course. When unstabilized, it should coincide with the zero of the bearing scale. If not, again, it as per manufacturer's instructions, usually a spring-loaded knob is to be pulled out or pushed in, rotated as necessary, and then released. 14. Gradually increase the gain until the receiver noise is just visible as a speckled background. The setting of gain would have to be reduced when sewing short range scales. 15. Test the efficiency of the set as described later in this chapter. 16. Adjust other controls as necessary. So radar solution. There are two important factors in radar resolution: bearing resolution and range resolution. Bearing resolution is the ability of the radar to display a separate peeps to echoes received from two targets, which are at the same range and close together. It is proportional to the antenna length and reciprocally proportional to the wavelength. The length of the antenna radiator should be chosen for a bearing resolution better than 2.5 IMR resolution. This condition is normally satisfied with a radiator of 1.2 meters or 4 feet or longer in the X band. The S band radar requires a radiator about 12 feet or 3.6 meters or longer.
Okay, so let us now move on to bearing accuracy. One of the most important features of the radar is how accurately the bearing of a target can be measured. So, of course, with this comes with proper installment and adjustment of the instrument. The accuracy of bearing measurement basically depends on the narrowness of the radar beam. So, however, the bearing is usually taken relative to the ship's heading. So, that means it is a relative bearing because it is with respect to the ship's own heading. Thus, proper adjustment of the heading line at installation is an important factor in ensuring the bearing accuracy. So we need to make sure that our heading line is properly adjusted and it is already accurate because of course it is going to be the reference point of our bearing. So to minimize error when measuring the bearing of a target, put the target echo at the extreme position on the screen by selecting a suitable range for the bearing. So next is range measurement. Now range measurement is equally as important as the acquirement of the bearing of a target. Measurement of the range to a target is also a very important function of the radar. Now, generally, there are two means of measuring range. The first is the fixed range rings. The second one is the variable range marker. So, in the fixed range rings, these appear on the screen with a predetermined interval. So, you can either choose from 3 nautical miles to 6 and 12 and other options. So they provide a rough estimate of the range to a target. So, for example, you use the range of 12 nautical miles, and there are actually six rings from the center. So that means in every ring, it is roughly 2 nautical miles away from each ring. So the gap between two rings is 2 nautical miles. So that is one example. So it depends on the range that you have chosen. So the variable range marker's diameter is increased or decreased so that the marker touches the inner edge of the target. Now, while the fixed range rings are actually fixed, so it cannot be moved or manipulated, and the VRM or the variable range marker can is a circle in which its diameter can be increased or decreased. You're going to drag this and put it in the edge or at the center of the target, so allowing the operator to obtain the more accurate range measurements. So to show you what this looks like, so as you can see in the illustration, so we have a radar. So if you see the line going, if you see the line that is the electronic bearing line, so that is the EBL, or yes, the electronic bearing line. So it is what we use to acquire bearings of targets. So in respect with our own vessel, so these are relative bearings. So the second one, or the circle with a circle with a broken made up with broken lines, is the VRM, or the variable range marker. This can also be dragged to increase to or decrease the diameter, and again you're going to put it in the edge of the target. So that is what it looks like in this in your screen or your radar screen. So now that ends our report. So I hope you have learned something. Thank you and God bless.